So finite state machine here, the word machine, you can compare or it is analogous to the program. The program which you are writing in any language like C, C++, Java, Fortran, you consider any programming language, computer language. So the machine term, it is analogous to that program. And you all know that the one particular program, it comprises of multiple functions, and for each function you are assigning some specific task, right? So the program, it is a collection of functions, and your state, this term from finite state machine, the term state, it is analogous to those functions. So machine is a program, and state are nothing but the functions. So the finite state machine, you can say uh, it is just a program. That program will have finite number of functions, but these functions or these machines will not have the memory to store the intermediate results, right? So how it works and what is finite state machine, that we will see. So before we will go with, I'll explain more about a finite state machine. Let's take a look on basic machine. So you consider any machine. It can be a washing machine, it can be an electric fan, or it can be just a mixie. Any machine if you take the example of any machine, you know that for each machine for each machine you need to give some input, or a machine needs some input, and depending upon the input it will produces the output. So what input it will take, so that is also fixed. So the input, uh, there is always the acceptable set of input for any particular machine, right? You can't give any input to any machine. That is not possible. So the it is fixed that what type of input that particular machine will accept, and depending upon the input which you are giving or which that machine is getting, it will produce some output. So input, it is coming from a particular input set, we can call it as I, and it produces some output, and that is also fixed. For one particular input it will give the specific output, for another input it will give some other output. So the output is also, it is fixed, and you can call it as output set, capital O. So in case of basic machine, uh, we are not emphasizing on the behavior of the machine or how that you will get the output. Basically it is focusing on what output you will be getting after giving the particular input. So in basic machine we focuses mainly on what is the output, and not on how we will get that output, or you can say in other words, we are not focusing on the behavior of the machine, right? And this machine will have the MF, which is called as a machine function. So it maps your input with the output. So here you can say, here you have input I, that input set I, it is mapped with output set O. So take the example of AND gate. So though it is there in front of you, uh, you can think that if it is a input AND gate, what type of input AND gate will accept, and what type of output the AND gate will produce on that, after getting the particular input. So AND gate, it can accept the input 0 0, 0 1, 1 0, and 1 1. So when two inputs are given 0 0, if this pair of input is given, you know what will be the output, right? After giving input 0 0, you know the output will be 0. After giving input 0 1, the output will be 0. After giving 1 0, it is 0. After 1 1, the output will be 1. So it means for two ones, for AND gate the output will be 1. So if you'll see this capital O here in the table, So you are having only two type of outputs, that is 0 and 1, and that is the reason here in capital O you can say it is a set of two elements 0 1. Whereas if you'll say the input row, it is a pair of 0 0 0 1 1 0 1 1, and accordingly it is there in input set I, right? So here we are not emphasizing, or we are not thinking how this output is produced. We just know that the input this is given and expected output is this. We also know ki what will be the output, so we can predict after giving input as a 0 0 the output will be 0, that we know. So we are not thinking that how this AND gate is producing the output. Similarly, if you have a decimal to binary converter, that can be the machine, electric fans, washing machine, weighing machines. So all these machines, these all comes under the basic machine, and here we are just giving the input and we are getting the output. We are not thinking how we are getting this particular output. But if you take the example of finite state machine, here we have to think about how we will be getting the output, or what will be the behavior. So when you're talking about the behavior of the machine, you have to think about the different states or different functions which are which you are implementing, which you will be implementing, or the functions which are a part of that program. As I said, ki machine, it is nothing but a program, and states are nothing but the functions. So when you're talking about the behavior of the function, it means you have to think about the behavior of the various states of that program or of that function. So uh, once for each particular state, you have to think ki after getting this input, what should be the output of that particular function or a state, and how that output will be produced, right? So finite state machine, here it has MAF, machine function, same as your basic machine. And here you can see that here it is not mapping your input with the output, but here the input to which state you are giving, what input to which state you are giving, depending upon that the output is decided. And that is the reason here MAF, you could see that the input and the current state, it is mapped with the output. So किस function को क्या output आप input आप दे रहे हो, depending upon that that function will produce the output, right? So this is your MF. For STF is another term, it is called as a state transition function. So here basically the way you are calling one particular function x, and that x is calling y, then y is calling z, again z may call either y or x depending upon again the input or what output you are getting. So here the STF, it maps that after getting a particular input to the current state, to which state it will go or to which function it will call, right? So this STF will basically decide the flow of the program, and MAF will tell that after getting the particular input to the function, what will be the output. And S, it is nothing but the finite state of internal state. So all these states which you will be specifying in MF and STF, it will come from this capital S. Then whatever input you are giving here to any function or to any state, those symbols or that input, it will come from I, and the output which your functions will produce, that will be from this state O. Okay, so after this, we will move to the example. Take the example of binary adder. So binary adder, you all know that to the binary adder, we are giving two inputs, and depending on that, we will be getting the output. So binary adder takes the input as 00011011, and depending on the input and the what carry that the input will have, it will produce the output. Now here you know that binary adder will have this input from the input set I, and it will produce the output from the output set O. And the input and output set both you can see in front of your screen. And as I explained earlier, it has a MAF. So MAF, it matches your input with the current state. It matches your input and current state with the output. That uh, which is your current state, which function you are executing, and the function which you are currently executing with some input, and depending on that you will be getting the output. This is what is the meaning of MF. So here the function is nothing but the state you are in currently. So that state will get some input, and to what state it is, depending on that it will be, and what input it is getting, depending on that you will get the output. So your state and input both are important. And in case of STF, the state will get some input, and depending upon the state it will get transited to another state. So here also state and input is important, and depending upon these two it will decide the transition, or it will decide to which function it should call. So let's say the MAF and STF for binary adder. So when you have 00 as an input, and consider that there is no carry, so the output will be 0. And if you have a carry 1, so output will be 1. If the input to the binary adder is 0 1, and if there is no carry, so output will be 1. But if there is a carry, output will be 0. Now if there is 1 0 input with no carry, output is 1. With carry, output is 0. If it is 1 1 and carry, output is 1. If no carry, output will be 0. So so here you can see the output of the two binary digits. It basically, it depends upon the carry which you are adding. If there is a carry, the output will be different. If there is no carry, the output will be different. So carry is an important element which is changing the output, and which can also change the transition. And that is the reason the carry and no carry, these are we have considered these two as two different states. So carry is one state and no carry is another state, right? So if you'll see STF here, so when you are adding 00, right? When you are adding 00, and if you are on the carry state, so definitely with this 00, one more one will get added because it is a carry. So after adding 00 and plus this carry which is 1, it will not generate any carry. So carry will not be generated, and that is the reason you will be moving to the no carry state. If you are adding 00 with no carry, that is there is no carry, you will be adding 0. So it means there is no generation of carry, so you will remain on the no carry state. If you're adding two digits, 0 1 binary digits, and with this 2 0 1, if there is one carry, that is 1, so definitely the output will be 1. Sorry, the output will be 0, and it will generate carry, and that is the reason the carry on this input 0 1, with carry state you will be on carry state, because here the carry will be generated. But if 0 1 input is given to the no carry state, it will not generate any carry, and that is the reason you will be transited to no carry. Similarly 1 0, if two numbers as given as an input with carry, it will generate carry, and that is the reason you are on the carry state. If there is no carry, you will remain on the no carry. But if the input is 1 1 and the carry is also there, so definitely three ones, when you will add, the carry will be generated, and that is the reason you will be on the carry state. And because there is though there is no carry, but because of two ones it will generate one carry. So if you'll now this what we have, this example in STF and MF, we were thinking of two binary digits, either 00, 01, 10 or 11. Now we'll try to apply this uh, on the number, so where you will have multiple binary digits. So if you'll consider this, if this is your 17 and if this is 19, and now if you are carrying this, so when you are carrying two ones, so if you'll see MF, if you are carrying two ones, the output will be 0. So output is 0 and there is a carry. So you can see the carry is written here. Now here if it is 1 0 you are adding, you can say here it is 1 0. So the with no carry output is 1 and with carry output is 0. So 1 0 you are adding and with carry 1, so output is 0 and again next carry is added. So you know this addition, right? So you can apply this MAF key after adding the two binary digits with carry or without carry, what will be the output, and accordingly you can cross check the answer, right? So after doing this, the complete addition, you can see the answer written here in front of your screen. Now here you have another number, it is 1011 and 1111. Again here also you can apply, because this is the very first rightmost two digits you are adding, two binary digits, 1 1. So that obviously there is no carry. It is a very initial state from where you will start the execution of your program. So when you will add these two numbers, output is 0, carry will be generated, and carries, all carry, you can see it is written here, these are all carries. So you can say the output is here, then carry is written here, three ones you are adding, output is 1, again the carry here, you got output 0, again here it is, this is carry, three ones are added, output is 1, and this is your extra 1 which is generated. Now if you'll try to compare, now initially when you are adding two numbers, 1 1, so you are at no carry state, because this is the very first, uh, yeah, it's the initial state, from here you are starting your execution. So when you are adding two ones, obviously there is no carry, these are the very first two digits, so you are on no carry state, and then it has generated carry, so your next move is a carry, so now you are on a carry state. So next input is again 1 1, but carry. So output you got as 1 and carry generate ho raha hai. So that is the reason you will move to the carry state. Again you are on a carry state. Next input is 0 1. You can see here 0 1 with 1 carry. Output is 0. Carry generated. So definitely you will move to the carry state. So last two input, last two digits 1 1 with 1 carry. So output is 1 and carry is generated. Now this carry, no carry, you can see here in the transition diagram. So you will be starting with the no carry and give your input. It can be 1 1, it can be, because we are writing, making it generalized. So to the very first state, you can have the input at a 0 0, you can have 1 0, you can have 1 1, you can have 0 1, and you have to check if the input is 0 0 and there is no carry, output will be 0 and you will remain here. If your input is 0 1, output is 1, carry generate nahi ho raha hai, so you will remain here. Now your input is 1 0, so output is 1, but carry generate nahi hua, so you will be here. Now to this state, if you are giving 1 1 as a input, output generate ho raha hai और carry भी generate हो रहा है, so you got moved to the carry state, right? Now again here to the carry state, Again, you can have input as 0 0 1 0 1 1, 0 0 0 1 1 0, or 1 1. All these four inputs again, you have to give to the carry state. Now if the input is, let's say, 0 1, so and you are on a carry state, so definitely the output is 0, and you will remain on the carry state, because after adding 0 1 and one more 1, carry generate hoga. If 1 0 is the input, and if there is a carry, output generate 0 hoga, and you will remain on the carry state, because here also the carry will be generated. Now again, input is 1 1 and carry is there, so output is 1 and carry generate 2, so you will remain on the carry state. And if the output is 0 0 with the 1 carry, so output will be 1 and carry generate nahi hoga, and that is the reason you can see there is a transition to the no carry state. So this is how it will work.